Now in this case, I think it was easier to solve for x than it was for y. I could rewrite that last equation as 8x equals 6y minus 10. And so that means x is going to be 6/8 of y minus 10 over 8. So just to simplify as far as we can, that means x is going to be, 3/4 y minus 5/4. So, what are we down to now? We were finding the equation, or we were finding the intersection point between two circles, and now what we're doing is finding the intersection point between one of these circles and this line. So where does this line show up on the graph? Well, there's a line connecting those 2 points, right? If you put a line right here that's connecting those 2 points, the equation of that line should be exactly x equals 3/4 y minus 5/4. Alright, so how did we find the intersection point of a circle and a line? Well, let's plug that back into one of the circles. If we plug it back into the first one, what I've got is, what was it? X minus 3 squared plus y plus 2 squared equal to 25. Alright, so if I replace that x with 3/4 y minus 5/4, that will be minus 3 squared plus y plus 2 squared equal to 25. And what kind of equation is that? Well, you ought to be able to recognize that as a quadratic by now. It's an ugly one, but it's a quadratic. So, let's go about solving it like it's a quadratic. We're going to have a y squared term from here and also from here. So we're going to need to collect like terms, which means unfortunately we have to multiply everything out. Now I'll save you some of the details here. If you collect like terms here, what you should get is 3/4 y minus 17 over 4 squared plus y plus 2 squared equal to 25. Let's simplify it as far as we can before we start squaring it out. And now let's square it out. I'm going to get 9/16 y squared from the first term. I'll get the cross term twice, so I'll get minus 2 times 3/4 times 17/4 y. And I'll get the last term squared, which will be 17 squared over 16. Now for this part, I'm going to get y squared plus 4y plus 4, and all of that's equal to 25. So we need to collect up some like terms here. Alright, if you look at my y squareds, I have 9/16 of them here, and I have one of them here. I believe 1 and 9/16 is 25 over 16. So 25 over 16 times y squared. If you look at my coefficients of y, I've got this number of them here, and I've also got this 4y here. If you combine those together, again I'll save you the arithmetic, you should get 38 over 16 times y. It'll be negative. And then your last constant term here, we've got this 17 squared over 16. We've got a 4, and we'll be subtracting 25 from both sides. If you collect up those like terms, and check me on this, you should get minus 47 over 16. So all that's going to be equal to 0. So now finally we've gotten this down to an equation we can solve. I would say let's go ahead and multiply through by 16 just because it's kind of ugly the way it stands. Alright, so what we've got left is 25y squared minus 38y minus 47 equal to 0. Now that's something I can punch into the quadratic formula. So y should be what? Negative b plus or minus square root of b squared minus 4ac. Don't forget the negative on that 47. It means we'll actually be adding two things under the square root. Alright, that's over 2a, which is 50 in this case because a is 25. So this simplifies to 38 plus or minus the square root of, I believe this number is 6144. Check me on that. And that's over 50. Now if you want to simplify that I believe 6144 is 6 times 32 squared. It took me a few minutes to figure that out, but what that means is you can leave the 6 under the radical but pull the 32 out. So this is plus or minus 32 square root of 6 over 50. And honestly, I think I would leave it at that. You could maybe divide everything by 2, but that's about the best you're going to do on that. So if you wanted to simplify that, you could make this 19 plus or minus 16 root 6 over 25. But that's about as far as I'd go with it. If you actually want to figure out what these things are, let's go ahead and punch them into decimals. What I get for the positive answer is about 2.3277, and for the negative answer I get negative 0.8077. Now what was it we just found? We just found the y coordinates of these two things. So how do we find the x coordinates? Well, remember we have a relationship between x and y. So recall, we found out that x was equal to 3/4 y minus 5/4. That was something a couple of pages ago. So if I plug in x equals 2.3277, my mistake. If I plug that in for y, then I get x is approximately 0.4958, and if I plug in y equals negative 0.8077, what I get is that x is approximately negative 1.8558. So what does that mean my two ordered pairs are? It says that one of them should be approximately 0.4958, 2.33, and the other one should be approximately negative 1.856 and negative 0.81. So, well, final test, let's see if it looks right. If I go forward by about a half, I think that's one of these units, and up by about almost 2.5, that'll get me to this dot right here. So it looks like this one is going to be 0.4958, 2.33, that looks about right. How about this one here? Negative 1.8, negative 2 would be this hash mark, and it's a little short of it. And negative 0.81 will be just a little above negative 1. So that should be our point here. Negative 1.856 and negative 0.81. So we've got our two intersection points.